In this first session, we're going to do an introduction to statistics. Statistics, or typically as I refer to them, stats, is the methodology for collecting, analysing, interpreting and drawing conclusions from information. Essentially everything that deals even remotely with the collection, processing, interpretation, or even presentation of data belongs to the domain of statistics. There's kind of these two broad categories that we could break that down into though. First off, the collection of the quantitative information. That's something we've already looked at on the ClinDoc module NERP D3 in terms of quantitative study design, study types, and that kind of quantitative data collection element. But this could also be things like collecting data from the census, from hospital records, or again, you going out as a researcher and collecting that data itself. Then the sort of second broad category within statistics, which I guess is what most people might think of as actually doing the stats element, is methods for handling that data, ways of organising, summarising and describing it, and I guess more the kind of real statistics of the methods of drawing inferences and generalising from that data. But as you can sort of see, statistics is broad and it can have these two kind of categories within it. So, we have to, again, apply the same kind of methods, apply the same rigorous learning and the rigorous knowledge that we create in academia to making sure we do things right, that we collect the right kind of quantitative information in the right way, and then we handle it and analyse it in the right way too. There's typically what I would say is sort of four main questions when we're dealing with quantitative methods and using quantitative data. First off, what kind and how much data need to be collected? Now, I'm not going to give you specific answers to these questions right now, obviously, but these are some of the things that you need to be thinking about, particularly when you're going on to do your project. But any time we're thinking about doing a quantitative analysis, quantitative project, we need to be asking these kind of questions and coming up with some kind of answer and a justification for that answer. So what kind and how much data need to be collected? What's the kind of minimum? What's the maximum? What is it that we need? How should we then organise and summarise this data? So once we've got it, what are we going to do with it? How can we then analyse the data and draw conclusions from it? So it's not just enough to kind of get that data and organise it and put it out there. We need to kind of potentially do some more things and again relate that to the real world. And then how can we assess the strength of the conclusions and evaluate their uncertainty? So in this element, how good is our data? How good is our findings? Can we be confident in the messages that we're putting out there? And within that, there's probably three main stages within doing quantitative data analysis: the design, the description, and the inference. And this is kind of how we're going to look at the material today, particularly stages 2 and 3. Stage 1, the design phase, about planning and carrying out research studies, is essentially what you've done in the previous sessions, looking at the quantitative study design, the material that I provided, and then the quantitative data collection element. But how do we then take the design and actually go out and collect that data itself? Stage 2 is the description. So this kind of element, we've got the data in hand, we're going to summarise it, we're going to explore it, we're going to look at the kind of general patterns that we see in it. But then we need to then potentially take that on to a third stage, which is the inferential statistics element, which is where we want to try and make predictions and want to generalize about the relationships that we see in our data. So it's basically how our data relates to the real world out there. So what we're kind of finding, how does that correspond? Description doesn't really do that. Description just says, this is what I've got, here it is, I'm presenting it. So if we want to then look at the real world, we want to apply it to clinical practice, we want to apply it to policy making, we need to have some kind of thought about what that data and what those results actually mean. So in terms of why we need to have some knowledge of statistics, and often in these sessions, whether doing face-to-face or online, people often start off with that sense of, I don't want to do quantitative methods, I don't want to do quantitative analysis, and I don't think I'll need to do it. So why do I need to do these sessions? Now, I think there's kind of two kind of key reasons why I think it's important, even if you're never going to do statistics data handling yourself beyond these kind of sessions. First off, if you want to read and evaluate other studies out there, it's really good to have some basic stats knowledge, because there are going to be times where you need to read quantitative elements in a project. There's going to be projects that have quantitative data. So if you don't understand what's going on there, then you're going to be at a disadvantage. For example, here we've got a quote that was taken from a paper So they're saying there's a significant improvement in depression mean score for the CBT intervention group compared with the control group. And then they present this data here. They have a t-value and then they have a p-value. Now, if you have no idea what those mean, you cannot then say, well, that statement in there about the significant improvement, whether that's an accurate statement or not. So does this statement mean anything robust? That's where we use the statistics, those t-values and the p-values, for example, there to substantiate the claims that are being made by the author. So we can look at that and say, well, I understand the p-value relates to probability. It's below a certain cut point. It's a relatively small number. I can feel confident that what they're saying there is an accurate reflection of what they've done. So having that knowledge of being able to critically appraise and judge other studies out there, whether that's in an academic side or whether that's in your own clinical practice, is a really important tool to have. And I think that's where this material will be helpful for some, and for others it will obviously generate, that ability to carry out some quantitative analysis yourself. And so the second reason is about statistical literacy is needed if you're going to undertake the study and collect and analyse that data yourself. So you need to understand what you're doing and what the results mean. And you need to plan your study anticipating the appropriate stats methods that you're going to be using in the analysis. In this slide, I've just kind of noted some things that I think, again, are valuable about stats and some of the limitations that we have about stats. In terms of the so-called good, stats can help us describe data and test relationships about things of interest. They're a tool that help accept or reject a study hypothesis with some kind of degree of confidence, or what in sort of the jargon, or the particular term we use is probability. So it's how confident we feel about the evidence that we've created and the results that we have. The so-called kind of bad elements of statistics is that the stats by themselves cannot make up for poor data quality. If we design a study poorly, if we make mistakes when we collect the data, we can't really fix those problems later on. Those problems are going to be there, and we're going to just have to deal with them, and it potentially can ruin a whole study. So we can't just wait and do the statistics as something that's going to solve previous problems that have either been created deliberately by mistakes that we've made, or something that was unforeseen that happened during data collection. And statistics can't prove anything. It's just an indication of whether study results are a result of chance. I think this is always an important thing to consider, that the p-values and the results that we get in any kind of statistical model, they don't understand what's in the model. So they don't understand if you're looking at blood pressure, or you're looking at cancer, or you're looking at a hospital, or you're looking at an individual. They just see the numbers, the stats models, and it's really up to us to interpret the findings that are in there. So are things clinically relevant? Do they make sense? Is there a plausibility in there? So the stats themselves don't really prove any of that. They just simply say there's a pattern here which is unlikely to be due to chance. So there's something going on. It's up to you to figure out what that something is by your knowledge of the area, your knowledge of statistics, your knowledge of your clinical practice to understand what's relevant and what's maybe a spurious result that we might find. So thinking ahead before we obviously go through the next round of material, and also kind of thinking ahead to your potential ClinDoc projects that you'll be looking at. For those that are thinking of doing some kind of quantitative element, even those that aren't, but again, I've mentioned this before, I'm hoping to convert you to the dark side a little bit. Think about your study design now, whether that's going to be qualitative, quantitative, mixed methods. What I would recommend is making sure you try and keep your study design as simple as possible. Some of the best RCTs are, a relatively straightforward control intervention group, and it just requires what we call a t-test, something we'll look at later on. Design your study trying to know what stats test you will use, so don't make analysis an afterthought. And this happens a lot, that people have a really good idea for a study, they get the design really right, and they think, well, I don't really want to think about the stats right now, I'll worry about that later when I come to analyse the data. And then they realise at that point, when they come to do the statistics, that they can't do what you originally thought you were going to do because something doesn't match up between the study design and the data collection and the statistical models that we look at. Now, understand the test you're using in the analysis. So this will be important, obviously, for the rest of this module when you're doing your assignments, about trying to understand, what you're doing and why you're doing it to get the right answers. And then when you're doing a ClinDoc project that does have a quantitative element to it, you also want to understand what is it you're running in your model. And sometimes what happens, particularly when we're not experienced in using statistical methods, is that we find resources online or through this kind of material, we run our models, we take everything out, we put it into our thesis or our paper, and we just kind of leave it there. It's really important to try and understand what those tests are showing you and also what they're not showing you in order to make that next step to interpret the data in the correct way.